Hello everyone, welcome to today's class. In today's class we will be looking at a very important topic, and that topic is projectile motion. Now projectile motion has come to stay, and if you check most physics questions, you will see that the first two questions are always projectile, and this has been creating a lot of difficulty for some students because they tend not to understand the concept behind solving questions under projectiles. Now if you check this, in this question in this note I actually underlined some keywords, so please make sure you pay attention to all these words. Now, projectile motion refers to the motion of an object projected into air at an angle theta with respect to the ground. That is projectile motion. So when you are defining projectile motion, the keyword there, motion, is very important, and that word projected into air is also very important. Now, after that, there is another thing that is called projectile. Projectile is an object launched into space and is free to move under the influence of gravity. So the word launched into space and free to move under the influence of gravity is very important, very important. So please make sure you pay attention to all these keywords. And there is another aspect of this topic that usually comes out a lot, and that is examples of projectiles. Now, in dealing with examples of projectiles, I've tried to categorize them under the ones used in sport and the ones used in warfare. So now you will see that in this question we have kick football, throw javelin, throw baseball, the movement of a table tennis ball when it is being played. All these are examples of projectiles used in sports. The key word there is kicked. You don't say football, you must put the word kicked football, because if the word kicked football is not there, then you are at the verge of losing marks. So, and for warfare we have shot bullet, thrown grenades, shot arrow. And now the next thing we will be looking at will be the description of projectile motion. Now if you check this, we have some terminologies, most especially for vertical projectiles, and that is why I've painstakingly put these notes together. Now there's something we call the time to reach the maximum height. This is the interval between the movements of its projection and the moment it reaches the highest or maximum vertical distance above the horizontal ground. And in most cases, as you all know, the formula for calculating that is u sine theta over g. There is a keyword there, and that keyword there is your Vy, that is the vertical components of your velocity or speed, is 0 at maximum height. Please always note this. Now the next thing we will be looking at will be the time of flight. Time of flight simply means the total time taken from the point of projection to the point at which the body lands on the horizontal ground. And something is happening here. Your vertical distance, which is vertical component, which is your y, will be 0 at the end of flight. That means the moment it touches the ground after it has been projected, that's y, that vertical distance must be 0. And if you go by the formula for time of flight, is usually 2u sine theta over g. And if you look at it critically, you will see that time of flight is actually 2 times the time it will take to reach the maximum height. Now, having said that, the next thing we will be looking into will be the maximum height. The maximum height is the highest vertical distance it reaches above the horizontal ground. And at this point, your vertical component, which is your Vy, of the speed must be 0. And the formula is always h maximum equal u squared sine squared theta over what? Over 2g. Now the next point we will be looking at will be the range. The range simply means is the total horizontal distance covered. Please, the key word there is horizontal distance covered. Very, very important. From the moment it is projected off the ground to the moment it lands on the ground. And if you check your range very well, it has like 4 formulas. Personally, I love to put all these formulas there because they will help you. R is equals to UXT. Now, UX is your horizontal component. UX is your horizontal component and is U cos theta. While your UI is your what? Your UI is your vertical component and is what? U sin theta. So, but here we are making use of this for range because range has to do with the total horizontal distance covered. Now, check very well. Your US is U cos theta. So I can actually write this formula as UT cos theta in case I'm giving the angle. But the first one is maybe I'm being told that the horizontal component of velocity is 20 meters per second while the time of flight is 50 meters per second. Of course, what I'll just do there is to multiply and I'll get my answer to be what? 1000. But if I'm giving this, then I'll be giving in such a way that I'll be giving the velocity of projection and the angle at which it is being projected multiplied by the time of flight. In this case, I'm giving the angle. So in this case, I'll just say R is equals to U squared sine 2 theta over G, which is very, very important. And another thing I want you to also note is there is something we also call the maximum range. For maximum range is usually U squared over what? Theta. The truth is that theta will be equal to 45 degrees. So at 45 degrees, a projected object will experience its maximum range. And if you put that here, that will be 2 times what? 45. That gives 90. Sine 90 is 1. That makes this to be U squared times 1 over G. Then you have this. Now, underneath here, I have some diagrams. These diagrams, they will help you to understand what we've been talking about since morning. Now, let's see. First of all, this is the point of projection. A body that is being projected will always describe a parabola path. We are going to get there in our as we go on in this class. Now, the total distance covered, the total horizontal distance covered is the range, while the total vertical distance covered is the maximum height. Now, as this body is moving from one point along the trajectory, is what? It will be experiencing some things, and one of them is UX. It will be experiencing the 2 components of its velocity. That means UX, which is cos theta, and UY, which is what? Sin theta. But something happens. As this body is going up, the vertical component, which is your UY, will be decreasing. And the moment the body gets to the maximum height, UY automatically becomes 0. That means at maximum height, the body does not have vertical speed or vertical component of its speed. That means the vertical component of its speed is 0. Now, something happens. The moment the body leaves the maximum height, it will again be experiencing its vertical distance, but this time around it will be downwards. As you can see the direction, here it was upward and here it's downwards. That means there is going to be a negative vertical component of its velocity, and that way it will